Is it on already?
It's on.
All right, cool. All right, so if you missed part in the video, I'm going to repeat this. We have two equations, x minus y equals -1, 3x plus y equals 9. And I'm going to give you two pictures of the same set of equations. One is called as a row picture. So let's plot these two lines. So we will plot the first row. So the first row is x minus y equals -1. So when x is 0, what is the value for y? 1. So the first point is x is 0, y is 1. That is 1 point. The second point is we will say y is 0, and then x would be -1. So when y is 0, x is -1. So y is 0, x is -1. And the other point is when x is 0, y is 1. So when x is 0, y. The 2 points. I'm going to draw a straight line joining these 2 points, and I'm going to extend it on both sides like so. Okay. Now let's take the second equation, 3x plus y equals 9. So when x is 0, y is 9. So when x is 0, y is 9. That's 1 point. So x is 0, y is 9. And the second point is when y is 0, 3x equals 9, x equals 3. So when y is 0, x equals 3. That's the second point. And I'm going to join these two by a straight line and extend it like so. Okay? And I find that these two intersect at a point, and the coordinates of that point happens to be x is 2, y is 3. And that is indeed the solution to this system of equation. So if you substitute x equals 2 and y equals 3, you will see that it satisfies the first equation. 2 minus 3 is -1. If x is 2, 3 times 2 is 6, y is 3, 6 plus 3 is 9. All right? So that satisfies. So this much you know from high school algebra. Now I'm going to give you a very different picture that you might not be familiar with, and that's the column picture. So instead of writing it in terms of row, I'm going to write it this way. All right? So I have the first column. Right? So I can take this, let's say I can write this as in the matrix form first. 1, minus 1, 3, 1. I call that a coefficient matrix. I take the coefficient of all the x and y terms and I put it in the form of a matrix. And I write x and y as a vector here, and minus 1 and 9. This is an equivalent form of this equation. So the way I go from this back to this is I take this first row. Okay, so it's fundamental matrix multiplication. I take this first row and line it up against this column. Now I want you to tell me what I'll get if I did that. So this first row, 1 minus 1, multiplied by this column. So you'd get x times 1, y times -1 equals -1. So x minus y is -1. So do you understand the correlation between this one and this one? Anybody has any questions on that? So I take this by this column, set it equal to this. I'll take the second row, 3 and 1. 3 times x plus 1 times y would be equal to 9. All right? So you should be readily able to jump back and forth between pictures. All right? So now let's take a look at the column. The first column is 1 and 3, and the second column is -1, 1. All right, so I'm going to take the first column, which is 1 and 3, and the second column, which is -1, 1. And on the right-hand side, I have -1, 9. Okay? All right, and I'm going to put a little placeholder here. Something goes there. Okay, and let's see what I'm trying to accomplish here. I'm going to draw another plot here. Okay, 2, 4, 6, 8, 10, minus 2, 2, 4, 6. All right, so where would the first column be? It's x is 1, y is 3. So x is 1 is here, y is 3 is here. All right, and it's only 1 point. So what I'm going to do is I'm going to draw a vector like so. That represents my first column. And column is x is negative 1, y is positive 1. So x is negative 1 and y is positive 1. That's my second column, and I'm going to draw that in red. Okay, and is negative 1, 9, and that point is all the way here. Negative 1, 9, somewhere here. Okay. So the column picture translates into this in English. I have to take certain number of green arrows, certain number of red arrows to go from, to get the black arrow. All right? So, and I'll give you the right answer, then you can tell me if it makes sense. And we know the right answer, right? 2 and 3. So I'm going to take 2 green arrows and 3 red arrows and the black arrows. This is green arrow. And I'm going to put another right this way. So the green arrow, you move 1 to the right, you go 3 up. That's a green arrow. So I'm going to move 1 to the right and I'm going to go 3 up. So that's my second green arrow. Alrighty. Looks like I can't have a green arrow. Yeah, it was fine just a few seconds ago. Okay, let's pretend this is green. Okay. Okay, so the dotted one is a green arrow. So I took 1 green arrow, I took a second green arrow, and now I'm going to take 3 red arrows. The red arrow is 1 up and 1 to the left. All right, so I'm 2 to the right here. So if I go, and I'm at 6, so 1 would take me there, the second one would take me there, and the third one would take me there. So I took 2 green arrows and 3 red arrows, and I got to the black arrow. So in this box, I'm going to put in 2 red arrows, or 2 green arrows, 3 red arrows, and you get a black arrow. All right, so that's called as a column picture. It's a linear combination, right? You're taking some amount of this vector, some amount of this vector, and you're getting this vector. The amount that you take is also the point of intersection of these 2 lines. All right? So in math, you need to be comfortable with both pictures because this is a very simple 2-dimensional problem. All right, so if I had a 3 by 3 matrix, that's a 3-dimensional problem. So instead of 2 lines intersecting, if I had a 3 by 3 matrix, you would have 3 planes intersecting. All right, so this is one plane, that's another plane, that's a third plane. All these 3 planes meet at the corner. All right, so let's pretend the sharp corner, plane 1, plane 2, 3. They all meet at one point. That happens to be the solution. All right, And I can increase the size of the matrix to 4 by 4, 5 by 5, 6 by 6. And if you're a mechanical engineer, which is what I am, I teach a course in your 6th semester where we take very, very large matrices, 1,000 by 1,000, and try to solve them. Okay? But the principle is that you can keep these two pictures in mind. Linear algebra becomes very, very simple. Okay? Any questions on this one? Yes?
If you put that on test, are you going to make us draw the graph, or can we just use the equation?
You should be familiar with 4 methods. One is a graphical method. All right? The second one is the matrix inversion method. The third one is something called as Cramer's rule. And the fourth one, let's see what the 4 methods the book would like you to know are. It's in the PowerPoint slide. The substitution method. That's kind of trivial, but let's do that as well, all right? So you should be familiar with all 4 methods. Yes, you will be asked one of these 4 methods. Okay. Everybody comfortable with these 2 pictures? Did you know of this method of looking at the same problem before? Yeah? I'm sorry? Algebra 2? Yeah, okay. Good. Now let's go. All right, so we start with an example problem. So you use Kirchhoff voltage law and write the 2 equations like so. All right, so 10 times I1 plus 4 times I2 equals 6 for the first loop. And for the second loop, 4 times I1 plus 12 I2 equals 9. So what you have now is 2 equations and 2 unknowns. And we are going to solve this using these 4 methods. Okay. The first method is rather trivial. And I'm going to leave the lights on, that way I could both show you that and try to do it by hand. All right, so the 2 equations are, so this one I'm not going to write on the board, it's fairly trivial. So what you do is you take one equation and you write one variable in terms of the other. All right, so from the first equation, you can say that, all right, so I take the first equation and I write I1 in terms of I2. And I take that value of I1 and substitute into the second equation. So if you look at this, I1 in this equation, it becomes one equation and one unknown because you've substituted for I1 in terms of I2. And you can very easily solve this to get I2. And once you have I2, you go back and substitute in either one of those 2 equations, and you can find I1. Okay, and I've also posted a MATLAB code that does this for you. All right, it's in Blackboard, and I'll give you a second to finish copying that. These notes are available on the Blackboard. If you'd like to solve it in class, that's okay, but you feel compelled to write these down. All right, so there's something called a symbolic variables in MATLAB. All right? So in I1 and I2, I'm using X and Y. So I can lead things in terms of X and Y. This is a very powerful tool, especially when you do calculus integration. So what I have is, I have 2 equations. Equation 1, all right, so it's a symbolic equation. So it's 10 times X plus 4 times Y equals 6. And if you looked at this one here, it's the same thing. 10 times x plus 4 times y equals 6. Instead of I1 and I2, I simply call them x and y. It's simply because it's convenient. And the second equation is 4 times x plus 12 times y equals 9, and that comes from here as well. 4 times x plus times y equals 9. Okay? And you write the two equations and you simply use the solve function. So you solve equation 1 comma equation 2, and you store the answer in this variable, in this a comma b vector. Okay? And if you run this, it'll give you the answer in fractional form. And to convert it into a decimal form, I use this conversion recipe. And it simply gives you the answer. So the answer is 0.3461 for x and 0.6346 for y. All right, so you can use this. Any problem that's given to you for homework, you can very quickly go ahead and simply change these 10, 4, 4, and 12, 6, and 9, and you'd get the answer in a flash like that. Okay? So feel free to use this. Okay? I'm giving you this code. The idea is for you to use this, that way you have the answer, and then you can also solve it by hand and get some practice, that way you know exactly what the answer is. And I have another code which does the same thing graphically. I use the command EasyPlot. Okay, so it plots the two lines and it gives you the point of intersection right there. So if you want to get a graphical snapshot of exactly what the answer should look like, you can do this and you'll get a good answer. Okay, so both codes are available for you, so please feel free to use them. All right, let's go back to the rest of our talk. So that's the first method. That's called as the substitution method. So you eliminate one variable or rewrite one variable in terms of the other, plug it back into the equation, you solve for one, you take that value of the variable, put it into the equations, and solve for the other. The second method is the graphical method. I think I did one by hand, and here's another example using MATLAB. Let's go to the third one, and that's by calculating the inverse of the matrix. So how to go from equation to matrix way of looking at the same thing. So you could take this, now that you have this picture, could somebody tell me what the two equations are? Let me see if you can work backwards. Yes. Very good. Excellent. Everybody comfortable back and forth between the matrix language and the two equations? Okay. So the first step is you take the two equations and write it in the matrix language. And we'll give these names. So pretend it's not a matrix equation, pretend it's simple algebraic equation. And instead of ax equal to b, we write it as b divided by a. All right? But in matrix speak, we call this a. All right? And a inverse of the matrix A. All right? And let's find out how to calculate the inverse of a matrix. All right? So if you have a matrix A whose elements were A, B, C, and D, and this formula calculate the inverse of this 2 by 2 matrix. Now let's calculate the inverse of our matrix here. So I want you guys to do it. I'm going to give you 2 minutes to do it. So our matrix A looks like this. 10, 4, 4, 12. All right, so let's start with 4, 4, and 12. Okay? The inverse of this matrix is 1 divided by the determinant of A. And how do you calculate of A? It's D plus B plus C. So what is times D minus B times C? That is 120 minus 16. Right? So 120 minus 16 is going to be 1 divided by 104. And you're going to have D negative B negative BA. D is 12. A is 10. Negative is negative 4. And negative C is negative 4. Okay? That's the inverse of your matrix. Okay? So we started off with A times X equals B. And X equals A inverse B. Now we have A inverse. A inverse looks like this. 1 divided by 104. 12, negative 4, negative 4, 10. And you let that operate on the column vector B. And B was 6 and 9. Okay? You have to carry out this matrix multiplication. Apply this. You would take this row, line it up against this column, and the answer would be, so 1 divided by 1, 12 times 6 minus 9 times 4, and 1 divided by 104, negative 4 times 6 plus 10 times 9. Okay. So 72 minus 36 is 36 divided by 104. And this one is 24, negative 24, positive 90. So that's going to be 66 divided by 104. All right, could you enter these two in the calculator, please? Yeah. Here, I took the okay, so the 1 over 104 stays as is. I keep that outside. I take this first row and multiply it by this column. So that's 12 times 6, negative 4 times 9. And the 1 over 104 is there on the outside. I'm not doing anything to it. Okay? For the second one, I do the same thing. I keep the 1 over 104 as is. Negative 4 times 6 plus 10 times 9. Okay? So remember, on the left-hand side, you have x, right? X is nothing but I1 and I2. So let me erase this to keep it clean here. All right, so A is a matrix, X is a vector, B is a vector. If I wanted the vector X, which has 1 column and 2 rows, you would take a 2 by 2 matrix and multiply it by 2 by matrix. Okay? All right, so we have I1 and I2 equal to these two. And what is this number? Somebody tell me what the answer is, please. So what is 36 divided by 104? The answer with the calculator, please. Somebody with the calculator, can you give me this answer? 0.346. Okay, and 66 divided by 104? 0.635. Now let's go and look at what MATLAB gave us. All right, look at that, 0.346 and 0.635. Okay, so this is the third method in which you'll be asked to do it. So the first one was substitutional or elimination, whatever you'd like to call it. The second method was graphical. And this is the third method. It's called matrix method. So you will find out what the inverse of the matrix is, and you will use the expression A equals A inverse times B. You'll carry out the multiplication, and you'll get the answer, right? Here's another quick cheat trick for you using MATLAB. Now it's so easy to calculate the inverse of A. Let me show you how to do that, all right? So what is the matrix A? Could somebody tell me what the matrix A is? 10, 4, 4, 12. All right. And I'm simply going to ask okay, so A inverse is as simple as that. All right, you put your matrix and simply type A inverse and it'll give you the answer. All right, and let's calculate A inverse times B as well. And what is the column vector B? What was that? I'm sorry? 6 and 9. All right, so B is 6, 9. And let's say A1, A2 equals A inverse times B. I'll simply put A inverse times B. All right, there you go. Okay, so the more you learn to use MATLAB, the easier your life becomes. So if they give you a large homework, you can always go to MATLAB and get a quick answer. And instead of actually sitting and calculating the inverse, though you should be familiar with this because in the exam you will not have the luxury of MATLAB. You will be asked to do it by hand. So you should know this as well. But always use MATLAB while you're practicing because you know what the answer is. And you know you're not making a mistake. All right, so the last method of doing this, so we did the substitutional method, we did the graphical method, we did the matrix algebra method, and the last one is called as a Cramer's rule method. And let's see how we can do the Cramer's rule. So if you had a 2x2 system like this, the first step is to write it in the matrix form, which we already did. Right? So the matrix form of this equation is all right, 10, 4, 4, 12, 6, 9. So A is 10, 4, 4, 12. B is 6 and 9. Okay, so the equation is of the form AX equals B. Okay, A is 10, 4, 4, 12. X is I1 and I2. And B is 6 and 9. All right, so to find I1, what we are going to do is, at the denominator, you're going to have determinant of A. Okay? Determinant of A is nothing but 10 times 12 minus 4 times 4. Okay? But let me, instead of doing it, jumping a few steps, let me add another step. So 10, 4, 4, 12. Okay? In the numerator, I'm going to calculate the determinant, not of A, right? So don't write this down. Could you pause and just look up for a second? So I have 10, 4, 4, and 12, what I'm going to do is I'm going to erase this first column here and replace that with this 6 and 9. Okay? Now let's calculate these two quantities, and let's see what it comes out to be. 12 times 6 is 72, 9 times 4 is 36, so it's going to be 12 times 6 minus 9 times 4. That is 36. And in the denominator you have 12 times 10 minus 4 times 4. And that's going to be 120 minus 16, that's 104. All right? And you divide these two, you get your answer, 0.3 something. Okay? Now let's calculate I2 and then you could write down. All right? I'm going to ask a volunteer to help me with this. All right? So the denominator is the same for both I1 and I2. So the denominator is going to be simply the determinant of the A matrix itself. And I'll write the same thing in the numerator, 10, 4, 4, 12. And what do I do next?
You would erase the second column.
Erase the second column, very nice, and replace that with?
With
6 and 9. Excellent. All right, and the answer is going to be 10 times 9 minus 6 times 4. 10 times 9 minus 6 times 4. And at the bottom you're going to have 12 times 10 minus 4 times 4. All right, 90 minus 24 is 66 by 104. And that's your answer. All right, I'll turn the light on and you can copy this now. That's the fourth and the final method. Yeah.
How do you know which one to multiply by?
This way, you mean? The determinant is calculated this way. You multiply this times this minus this times this. All right, and what does the determinant mean? All right, so let's say you had 3 vectors, a 3 by 3 matrix, right? And you know each one of those represent a vector. And the determinant is actually if you had 2 vectors that spans, you can draw an area that spans those 2 vectors. And if you had a third vector, you multiply that area by the third vector, you get the volume. So the determinant is really the volume spanned by those 3 vectors. And this quantity that you calculate also represents, so this is the area, and if you had a 3 by 3, that would be the volume. All right, so I'm going to talk a little bit about the homework problem. And you have a few circuits problems. So instead of giving you the actual equations, the book gives you problems you would see in real engineering practice, which is something like this. So you should be comfortable taking something like this and converting it into a set of algebraic equations. So if you're an electrical engineer, your problem would look like this. And if you're a civil engineer, your problem would look like this. I'm going to lower the lights. So what you have in this picture is you have 2 strings, or rods if you will, all right, or a truss member. So you can see a structure like this. If you take the regional rail train, the roof of the platform has these red truss structures, and the roof sits on top of it. All right? So these structures are designed to take tensile or compressive loads. Right? So here we have a force of 95 newtons acting. If the angles were same, the tension in those 2 structures would be identical. So if both were a 45-degree angle, they would have identical tension, assuming the area of cross-section and the materials are exactly the same. So in this case, we have a 30 and a 45 degree, and therefore we're going to have 2 different values for tension in those 2 members. All right? We will call one T1 and the other one T2. So in civil engineering and in mechanical engineering, and bioengineering as well, you'll do something called as a free body diagram. So what you do is, right now, that string is attached to the wall. All right, so it's not a free body. It has supports. So when you're drawing the free body diagram, what you would do is you would remove all the supports and simply imagine that the object is in static equilibrium by virtue of all the forces acting on it. All right, so I can draw, this is not a free body diagram. This is not a free body diagram because there's a table that's the ground. If I wanted to draw the free body diagram of this, I would pretend that I removed this table. And what should I replace that with? The table exerts a normal force from the bottom that supports the weight of this eraser. All right? So if I were to remove the table, it's going to fall down. And in order to keep it in equilibrium, I will supply a force equivalent to what the table was supplying. And that's called a free body diagram. So we have removed those supports, and now we have tension T1, tension T2 in the two members, and we have the 95 Newton weight acting downwards. Okay? So now any object that's in equilibrium is not moving, right? Force equals mass times acceleration. If the object is not moving, it's said to be in static equilibrium. Right? So the forces balance each other out. So if acceleration is 0, the forces must balance each other out. There are no forces. So all the vertical forces and the horizontal forces must balance each other out. So you use some basic trig here, and you write it in terms of vertical and horizontal forces. And let me do that for you. Okay, so here's the object. So I have 95 acting down, and I have T2 acting at a 30-degree angle like so. Okay, and I can resolve that into two components. So we learned this in the laboratory exercise where I was talking about one-link and two-link robots. So if I wanted the projection of this on the x-axis, what would this be? This angle is 30 degrees, so this would be T2 cosine 30 degrees. And this one would be T2 sine 30 degrees. All right. And how about T1? T1 acts this way, and it'll have two components, T1 sine 45 and T1 cosine 45 degrees. Okay? So let's look at all the forces in the horizontal direction. So this symbol here, sigma, represents the summation. So what this means is that the sum of all the forces along the x direction equals 0. Right? So what are the forces in the x direction? You have T2 cosine 30 to the right. Right is positive. So you establish a coordinate system. Right is positive, left is negative, up is positive, down is negative. Okay? So T2 cosine 30 is to the right, that's positive. T1 cosine 45 is to the left, that's negative. And that's how you get your first equation. T1 cosine 45 to the left with a negative sign, T2 cosine 30 to the right with a positive sign equals 0. Now we will balance the forces in the y direction as well. Right? So T1 sine 45 plus T2 sine 30 would be equal to 95 going down. Okay? So those are your two equations. So instead of giving you the equations as you might in a math textbook, we don't directly give you the equations. We give you an engineering scenario, and you should know how to take something like this and convert it into a set of algebraic equations. And then you should be familiar with the 4 techniques, and in the exam you will be asked to solve the equation using one of these techniques. And you'll also have to learn to develop the problem yourself. We won't directly give you 2 equations to solve this. Okay? There are 5 homework problems, I think, in your course outline, so make sure you solve all of them. Feel free to use the MATLAB to calculate the inverse or anything that you need. Use it as a tool to help you get through the homework problems, all right? But remember, you will not have the luxury of using MATLAB in the exam. So be very comfortable with the old-fashioned paper pen calculation, but also get comfortable with MATLAB. All right, I'll see you on Wednesday.